Hey guys, welcome to question MM408 of the Maths Methods Fortify study guide. So this is a 3-mark question in total and part A is 1 mark. A professional darts player can hit a bullseye 60% of the time. On any one turn consisting of 3 throws, what is the probability that he doesn't get a bullseye? Alright, awesome. Pretty straightforward question, just in terms of the maths, but recognizing what to do can be a little bit tricky sometimes. So what we're looking for is the probability that he doesn't get a bullseye 3 times in a row, okay? Now, before we can even work that out, we need to figure out what the probability is that he doesn't get a bullseye in one shot, okay? Because we can't do 3 throws unless we know 1 throw. So, if he has a 60% chance to score a bullseye, that means that he has a 40% chance to not score a bullseye, okay? So 40% in terms of a fraction, which is what I would advise changing it into because we don't have a calculator. That's 4 on 10, which is 2 on 5, right? So 2 on 5 is our fraction that has the probability of not getting a bullseye in one shot is 2 in 5, okay? Which means that the probability of not getting a bullseye 3 times in a row is, so not getting a bullseye, not getting a bullseye, not getting a bullseye. Each one of these has a chance of 2 in 5, which means that the whole path, 3 no bullseyes, 2 on 5 times 2 in 5 times 2 on 5. So equals 2 in 5 times 2 in 5 times 2 in 5, which equals 2 times 2 times 2, 8 over 5 times 5 times 5, which is 125. 8 on 125 is our first and only mark for part A. Guys, that's it for that. Let's move on to part B. Part B is quite annoying, to be honest. It's not a very nice question to do without a calculator, but you do need to know how to do it. So it is a 2-mark question, and we're looking for the probability that he obtains at least 2 bullseyes, okay? So what we're looking for is the probability that he obtains at least 2, which is equal to the probability that he obtains 2 plus the probability that he obtains 3, okay? Because we're only taking 3 shots. So we're looking for the probability that he takes 2 or the probability that he takes 3 or gets 3 bullseyes. Now, we are dealing with binomial distribution here, okay? Because we've got a 60% chance to successfully get any given bullseye, and whether or not he gets it on the previous turn doesn't affect the future turn, right? So that's binomial distribution. There's a success or a failure. So our binomial distribution formula tells us that probability that x equals x is equal to ncx times p to the x times 1 minus p to the n minus x. Now, what we are looking for is the probability that x equals 2 and the probability that x equals 3, which is why it's quite annoying to do without a calc. So what we're going to do is do this one first, and then we'll add this one on the end. So the probability that x equals 2 is, remember we have 3 throws, so our n is equal to 3, and our p is equal to 0.6, right? Which is 60%. So n is 3, c 2, times p, which is 0.6, and I'm going to change this 0.6 into a fraction, which is 3 on 5. So 3 on 5, and the only reason I'm doing that is just because we don't have a calculator, so decimals are really annoying to do with powers. To the power of x, which in this case is 2, times 1 minus p, which is 2 on 5, to the power of n minus x, so 3 minus 2, which is 1. That's this bit. Plus, now this bit, exactly the same thing. So n, which is 3, c 3, because that's our x value, times p, which is 3 on 5 again, to the power of x, which in this case is 3, times 2 in 5, because that's our 1 minus p, to the power of n minus x, which is 3 minus 3, so 0. Now, what we get then, actually this is our first mark in between here, what we then get, 3c2 is equal to 3, and then our 3 and 5 to the power of 2 is 9 on 25, 2 and 5 to the power of 1 is just 2 and 5, plus 3c3 is 1, 3 on 5 to the power of 3 is 27 over 125 times 1, right? Because 2 on 5 to the power of 0 is just 1. All of these added together, so these multiplied is equal to 54 on 125 plus 27 on 125, and this is equal to 81 on 125, which is our final answer. And this is our second mark for that question, and that actually wraps up MM408. Now, I know these are really, really annoying to do without a calculator, but sometimes you actually do have to do them. So you just got to see if you can get used to them and try your best. So guys, that's it for MM408. Let me know if you have any questions in the comments below, as always. But thank you for watching, and I'll see you in the next video.